This is a lesson about cumulative frequency and cumulative frequency curves. So I've got a table here. It's got people's heights in various categories. So for example, people with heights between 130 and 140, there's one of those. People with heights between 160 and 170 centimeters, there's 6 of those. And I've got a third column here that I haven't filled in yet, called cumulative frequency, and that's going to be the running total of people so far. So in the first category I've got one person, so that's a cumulative frequency of one person so far. And then in the next row I've got 2 more people in the next category, so that's 3 people so far. 1 plus 2 is 3. So that's telling me that there are 3 people with height up to and including 150 centimeters. Next category, 5 people, so that's 8 so far, and then another 6 makes 14, another 4 makes 18, another 3 makes 21, and then another 1 makes 22 people so far. So that matches the total of the column, of course. 22 people are in the whole thing. So I've got data about the heights of 22 people. And I'm going to plot this on a graph called a cumulative frequency curve. And these are the points I'm going to plot. So I'm going to plot 140 against 1 to show me that I've got one person with a height up to and including 140. I'm going to plot 150 against 3 to show that there are 3 people whose heights are up to and including 150. I'm going to plot 160 against 8 to show me that there are 8 people with heights up to and including 160. And then in a similar way, I'm going to plot 170, 14, 180, 18, 190, 21, and 222. So for each row, I'm plotting the height on the horizontal axis and the cumulative frequency on the vertical axis, showing me how many people I've got whose heights are up to and including that particular value. I'm also going to plot a point at the start, 130, 0, and that's going to show me that there are no people whose heights are less than 130. Okay, so here is that graph. I made it earlier. So I've got the heights on the horizontal axis, and I've got the cumulative frequency, not just the frequency, but the cumulative frequency, the total so far, on the vertical axis. And of course this graph is continually increasing because it's showing a running total of the people, so it's always going to get more and more and more. And then it eventually levels off at the point where we've got all of the people on the graph, all 22 people. So here are the heights from 130 to 200. Here are the people from 0 to 22. So I plotted the points first, of course, and then I tried to plot a smooth curve through those points. And it can be quite difficult drawing a nice smooth curve through the points. I took some time over this. When you're drawing a curve through points, it's easier to have your hand inside the curve. So I kind of drew that with my hand there. And then when you're drawing the curve going away from your hand, well, it can help to turn the paper around. So a little tip there turn the page around when you're drawing a curve going the other way. Anyway, this forms a sort of elongated S shape, and that shape is known as an ogive. So just worth knowing that word, although it's not really used much. So anyway, the middle person out of 22 people would be the 22 plus 1 divided by tooth. So that would be the 11.5th person. So the 11.5th value out of 22 is the middle value. So if we just take 11.5 here, we can look at the 11.5th person and read across on the graph and get a height that corresponds to the 11.5th person. And that turns out to be 165 centimeters. So we can say that the middle person has a height of 165 centimeters as an estimate according to this curve. So we can say that that's a good estimate from the median. Now, we don't know for certain because we haven't got the exact values of all the people. All we know is how they fall into categories. But this is a good way of getting an estimate of the median. Now, I can use the cumulative frequency curve to get estimates for the quartiles. If I think about the fact that I've got 22 people, a quarter of 22 is 5.5. So the 5.5th person is the person who would be 25% of the way along the data. So I can read across the 5.5th person just like that and get a value that is my estimate for the lower quartile. And in this case, it's turning out to be, well, I'm going to call that at about 156. So 156, I'm saying, is the height of the person who's 25% of the way along the data. So Q1, my lower quartile, I'm estimating at 156. And then similarly for the upper quartile, 3/4 of 22 is 16.5. So I can use my cumulative frequency curve to estimate a height for the person who's at the 3/4 point of the data, or the 75% point of the data. So I can read across from the 16.5th person until I get to the curve. And then I can get a value that is an estimate of the height, of the person who's 75% along the data. And that's looking like being about 176. So 176 is my value for the upper quartile, or Q3. So I've got my estimates for Q1, the lower quartile, Q3, the upper quartile, and 165 is the median. And I can represent these on a box plot. So the bottom of the box is the lower quartile, Q1, and I've got that at 156. The top of the box is the upper quartile, 176. The whiskers at the end of the box are representing the range of the data. So we know that it's no lower than 130 and no higher than 200, because those were the extreme values in the original table. And I've got the median at 165. Now remember, a box plot shows something about the central tendency of the data. So in this case it's showing you where the middle or the median is. And it also shows you the spread of the entire data, so that's the range. But as well as telling you the range, it also tells you the spread of the middle 50%. So that's the interquartile range. And that can be more useful because just calculating the range is just dependent on the highest and lowest value, and that could be affected by just a couple of extreme outliers. Looking at the middle 50% gives you a better idea of the spread of the data, because the middle 50% is more influenced by all of the other values. And in this case, the interquartile range is 176 minus 156, Q3 minus Q1, and that's a spread of 20 centimeters for the middle 50%. So 20 centimeters from Q1 up to Q3, the middle 50%. The interquartile range is 20.